All right, more practice with powers of complex numbers. So our first step is going to be to identify our A and B so that we can find R and theta. On part C here, A is 3 and B is -3. So R, again, this is on your equation sheet. It's x squared plus y squared, but you can call those x and y, you can call them A and B, whatever works for you. So 3 squared plus 3 squared is square root of 18, 9 plus 9. Square root of 18 we can break down to 9 and 2. So square root of 9 is 3. Radical 2 doesn't have a pair. There's our R. Theta, our tangent of B over A. So here's where we have to deal with the fact that arctan really only gives us values either in the first quadrant or the fourth, but we have to, for our complex numbers, we're looking whole unit circles. We kind of have to think unit circle backwards. If A is positive and B is negative, we should be looking for a quadrant 4 angle. And our quadrant 4 angle where tangent is -1 is 7 pi over 4. We are using arctan again in a little bit of a different way here. It's not really correct, I guess, to say arctan of -1 is 7 pi over 4. It's really negative pi over 4, but we're going to use that fourth quadrant value. Okay, so in polar form, this complex number is 3 radical 2 cosine of 7 pi over 4 plus I sine of 7 pi over 4. Since 7 pi over 4 and negative pi over 4 are coterminal angles, you could absolutely use negative pi over 4 in place of it. And we're doing, the power that we're doing here is to the 6th power. To apply our formula, we are going to do 3 radical 2 to the 6th. And then multiply 6 by our angles. And I'm going to write that 6 as 6 over 1. I'm going to let my calculator help me here. There it is. Sorry about that. So 3 radical 2 to the 6th power is 5,832. Times 7 pi over 4. Let's see what we can do with that one. 6 times 7 fourths. 10 and a half. Let's turn that into a fraction. 21 halves. Shoo. All right. Cosine of 21 pi over 2 plus I sine of 21 pi over 2. Now we do want our final answer in standard form, so go ahead and take a second, pause, and figure out where 21 pi over 2 would be. Find its coterminal angle by subtracting 2 pi. So by subtracting 2 pi, which is 4 pi over 2, you should have found that 21 pi over 2 is coterminal angle. It has a coterminal angle of pi over 2. I subtracted 4 pi over 2 a bunch of times. 6 times maybe? Now we're going to substitute in our values for cosine of pi over 2. Cosine is 0 at pi over 2, and sine is 1. Multiply in our 5,832, and we get 5,832i as our final answer. That was a big one.